Hi guys, so we are here with section 6.2 and I think you guys are going to like this section. So as a quick recap, in section 6.1 we talked about polygons and all the properties of polygons. From this point on, we're actually focusing on quadrilaterals, and that's going to be the rest of this chapter. So that starts off with our first vocab term, which is a quadrilateral. All right, and if you notice, I already have mine written out, but a quadrilateral is just simply a four-sided figure, okay? So just like there's like triangles and then there's specific types of triangles, the quadrilateral is just that like basic four-sided figure. So it could look like a rectangle if we wanted to, all right? Or we could make it concave, all right, where we would have it kind of jutting in, all right, and that's not a great picture because it's not closed in that one, all right, but these are both quadrilaterals, all right. This is convex, all right, this first one is convex right here, this is concave, okay. Now, we're then going to focus in on the different types of quadrilaterals, and then this entire lesson is specifically about parallelograms, okay. So what a parallelogram is it's a quadrilateral with two sets of opposite sides that are parallel, all right, hence parallelogram, okay? So what a parallelogram looks like is it's a slanted rectangle, all right? So the way that we're going to draw it is that it's a slanted rectangle, okay? And then based off of that definition, we know that it has two sets of opposite sides that are parallel. So I'm going to mark these sides right here parallel and these sides right here to be parallel. Okay. Now, the basic definition is telling us one property of parallelograms, which is that you have two sets of opposite sides that are parallel, but we actually have 6 more, all right, properties about parallelograms, okay? And this is something that you just have to memorize, okay? So what I want you to look at is over on the right-hand side of these properties, all right, I've gone ahead and actually drew out a parallelogram and then copied and pasted them all except for number 6, okay? So that's just going to be a time saver. So if you look at the first one, this is actually one that we just covered, all right, where the properties of parallelograms, one of the properties that we just stated was that the opposite sides are parallel. So if we come over here, we were given, all right, that these sides right here have to be parallel, okay? And that should be easy to memorize because of parallelogram, okay? Now, another property of parallelograms is that the opposite sides are congruent, all right? And I abbreviated that. I should have 2 sets of opposite sides are congruent. So what that means is that these 2 sides are congruent and these 2 sides are congruent, okay? Now, this is only true if we know that the quadrilateral is a parallelogram, all right? If we don't know that it's a parallelogram, we can't make these inferences, okay? Now, number 3 is that it has 2 sets of opposite angles that are congruent. All right, so if we go on to this little parallelogram, I'm going to mark this angle to be congruent to this angle, and then this angle congruent to its opposite angle. Number 4 is that the consecutive angles are supplementary, okay? So consecutive angles means that they are back to back, all right, that they're side by side, okay? So if we take a look at, I'm going to go ahead and highlight, I want to look at this angle right here, all right, and its consecutive angle right here, okay? We know that those angles have to be supplementary. So let's just kind of give an example. So let's say that this blue angle right here is 100 degrees, okay? If that blue angle is 100 degrees, what does that mean about the green angle? All right, well, that green angle then has to be supplementary to the 100 degrees, which means that this has to be 80 degrees, okay? But if we look back, all right, at that green angle, we actually have another supplementary angle to that angle, another consecutive angle, which is this one right here, all right? And so based off of the consecutive angles, this also has to be 100, which means that this angle right here has to be 80. Look at your opposite angles, all right? Once again, it is true up here, all right, that those opposite angles have to be congruent, which is what we just saw there. The other thing that we should recognize here on this one is that we actually have the background knowledge to say why the consecutive angles, all right, are supplementary. And what I want to look at is, I'm going to just erase that real quick. And let's remember that we're talking about parallelograms, which means that this side has to be parallel to this side, okay? And if I asked you again about this angle and this angle, all right, what special angle type are those? All right, those are same side interior angles, which we studied back in chapter 3. And we know that same side interior angles have to be supplementary. All right, same idea. If I know that this side is parallel to this side, and if I looked at this angle right here, all right, along with the green one, those are also same side interior angles, which means that they have to be supplementary, okay? One more step is if we look at the two blue angles, because they are both supplementary to the green angle, we know by the congruent supplement theorem that those two blue angles have to be congruent, all right? So those are just some background ideas of stuff that we've already talked about in this class, all right, that once again proves all of these properties to be true, okay? Now, really quickly, going through 5, 6, and 7. Number 5 says that the diagonals bisect each other. All right, so if I would draw in, all right, our diagonals, which are connecting two non-adjacent vertices, okay, the fact that they bisect each other, what I'm looking at is this point right here. If they bisect each other, that means that that intersection point has to be the midpoint, which means that this segment has to be congruent to this segment, and this segment has to be congruent to this segment. Now, look at my notation, all right? Not all 4 of them are congruent. It's that the diagonals are bisected so that they are splitting each other at the midpoint, okay? The 6th one is if one right angle, then 4 right angles. So what that means is if you were given, you had one right angle in a parallelogram, you can conclude, all right, that all of them have to be right. And that should make sense because of the fact that if this is a right angle, we know this also has to be a right angle because opposite angles are congruent. And we would know that this right here has to be a right angle because of the same side interior supplementary, which means that this one over here has to be a right angle because opposite angles are congruent, okay? Now, the last one is the diagonal split the parallelogram into 2 congruent triangles. So if I just drew one of those diagonals, okay, what it's saying is that those 2 triangles that I just created, all right, so this triangle right here and then this triangle right here have to be congruent. And it can be through any of the shortcuts, so side, 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 angle, side, angle, side, angle, 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 side, all right? And mostly just because, like real quick, this side has to be congruent to this side has to be congruent to this side, and then we could state that the opposite angles were congruent using side, angle, side. We could also state that this side has to be congruent to itself, all right, because of reflexive, which means that they're congruent because of side, side, side. And you could go through that with the other 2 as well, okay? So that's our vocab. I'm going to pause there, and then we're going to apply it, all right, for the rest of the notes.